So what can you do if you absolutely can't bear to get rid of your lovely elegant LINQ pipeline, but you still want blazing fast code? Well, let me show you a couple of options. The first is an ingenious open source project called LinqOptimizer. And what this does is it effectively compiles your LINQ expression down into the imperative code that you would have written without LINQ. And it's able to do this by turning your LINQ pipeline into an expression tree. And if you have a look at some of the performance tests they've done themselves, you'll see some pretty impressive results. So let's try for ourselves and see what it can do. I've added the LinqOptimizer.c# NuGet package to my LINQPad query, and this makes an asQueryExpression extension method available. So here I have exactly the same LINQ pipeline, except that I've inserted asQueryExpression onto the input data for our pipeline. And then when I'm ready to actually run the query, I need to call run. So let's try this and see what performance benefit it gives us. And as you can see, it's not only speeded up the LINQ version, but it's actually slightly faster than the non-LINQ version. Pretty impressive. And this LinqOptimizer package also lets you save even more time by calling compile up front on your query expression, like this. And so if you need to run the same LINQ query many times, you can save it a bit more time by pre-compiling it, just like you might be used to with regular expressions. Now, one important caveat about this library, the documentation does say that there are still many operators they have yet to implement. But it might be worth checking it out to see if it can give your code a quick performance boost before you decide to abandon LINQ. And obviously, whenever you're attempting to optimize the performance of some code, it's important to make sure that that code is well covered by unit tests. After all, it's no good making it run faster if you end up breaking behavior at the same time. Now, there is another trick you can use to speed up your LINQ queries, and that's to make use of parallel LINQ, or PLINQ. This allows you to make use of multiple threads to process your query, and using it is really simple. It's available in the .NET 4.0 framework and above, and here I've taken another copy of our LINQ query, and I'll enable parallel execution simply by adding the asParallel extension method. And this means that from this point on, PLINQ can use more than one thread to execute our query. So let's run this and see what kind of performance improvement we can get. As you can see, the results are pretty impressive. We've been able to halve the execution time because I have 2 cores on this computer, and so the work could be distributed evenly between them. And many types of query can be speeded up using PLINQ. For example, remember the RSS downloader LINQ query we looked at in the last module, and this spends quite a bit of its time just waiting for web pages to download from the internet. And there's no real need for it to be processing each element sequentially. And so with PLINQ, we can immediately kick off all 4 websites downloading like this by adding asParallel here. And then the time taken to get the total results will now just be the time of the slowest site. And you'll notice that as I run this, all 4 of the loading messages appeared instantly, and the total time taken is now just 3 seconds compared with over 7 seconds when we were running it before without PLINQ. And so PLINQ is really easy to get started with, and it can give you substantial performance benefits. And although I only showed off one method, the asParallel extension method, there is more to it than that. And so, for example, it will allow you to control things like exactly how many processors you want it to use. But the good news is that very often it really is as simple as just adding asParallel into your pipeline at the point where some parallelism would be helpful. And it's certainly worth a try if you've got large collections of data or have long-running methods in your pipeline. There is one caveat to be aware of though, and that's using PLINQ can make things go slower, because there is of course going to be some overhead in dividing the work up into tasks to be running on separate threads and then gathering the results back together when each thread has done its work. And so for very small queries, you could actually harm performance by using PLINQ. So once again, do remember to measure before you optimize. But hopefully I've shown you enough to persuade you that you don't necessarily need to give up on LINQ if you want high-performing code. Let's move on to look at another key to avoiding performance problems with LINQ, and that's understanding what's going on under the hood.